So what's going on, everybody? Today it's a sunny day in Amsterdam actually, so I don't know why, but I found the motivation to make a YouTube video again. And I think today's video is going to be pretty interesting because I was creating like a component for work the other day, and this is a simplified version of the component that is just used for like learning. But in writing this component, I actually was reminded about how React and JavaScript actually work under the hood. And I thought that, there's going to be something for everybody in this video, because if you're a vibe coder or someone who's getting into the industry using AI lately, then, this is good for your curiosity to understand how things work under the hood and maybe occasionally solve some bugs yourself if the AIs are still making them. And if you're someone who's actually like a full stack developer and you're still a junior and you're still using a lot of AI, then this video will just be good in case you ever need to explain why you actually coded things, or why you chose to code things in a particular way. What this component is actually going to show, it's going to show like the most common hooks in React: useEffect, useState, and useRef, and how they all work. It's also going to go into JavaScript's actual engine. So, how does JavaScript really work? It's a single-threaded language. It has like a call stack, it has web APIs and callback queues. So let's actually start with JavaScript. JavaScript is a single-threaded language, which basically means that it can only execute one line of code at any given time. So other programming languages aren't like that. For example, Java, you can have multiple lines of code executing at the same time because the language is capable of creating different threads that are all going to execute code kind of simultaneously. JavaScript was only created to be understood by the browser initially, and eventually Node.js came, which made it more of like also a server language, but it only executes one line of code at a time. And this diagram, I guess, explains that, and it's called the event loop. So everything that's on, and this is a bit more like technical, so if you do computer science, you probably know this, but the main code that's running is on the heap and the stack, and that always gets priority. These are just lines of code that get priority, but because we're in a browser, there are some things that can't happen immediately. So imagine you're executing lines of code, and then one line of code fetches data from an API. Now, you obviously don't want everything to wait for that one line of code. And because JavaScript is single-threaded, you might think that the whole language has to pause. And that's where the kind of event loop comes in. And what it does is, when you have something like a line of code that needs to wait, so this you usually do with the async keyword, for example, an API request, it is considered a web API. And that gets added to a micro queue. So you have everything that gets priority, let's just call it the queue. That's just regular lines of code that are synchronous. They're one after the other, and they don't wait on anything. And then you have asynchronous, and that goes to the micro queue. So these are, for example, like API queues. And these ones get a priority over these ones, so that when we're waiting for something, JavaScript can still keep on executing other code so that the whole application doesn't freeze. It's just waiting, and then when it has nothing to do here, and that's why it's called the event loop, it loops through its micro queue to see, is there anything that I was waiting for? And let's say the API returns data, then it will check in the micro queue. It sees, oh, okay, the API returned with data. Now let me get back to handling this. So it adds that back on the main stack, and it can keep executing. And that's how JavaScript doesn't get paused or stuck on lines of code that need to wait. So this was like this was a design choice based on how the web and browsers would probably work. And it kind of makes sense because, most of the time you're just executing code, and whenever you have to wait on something, add it to the queue. When it's done and you have nothing else of priority to do, just go and check and start doing those things. One useful thing to know is that, let's say you have 5 requests that are waiting. The moment it checks the micro queue, it's going to prioritize everything on the micro queue before coming back to the main queue. So if you have 5 things and they all responded, it's going to add all of those and empty the micro queue onto the main stack. So now we have 2 kind of queues. We have the main priority ones, and we have ones that wait. And there's actually another queue, which is for like interaction. And that one has the lowest priority. So you often have like an on click. So when a user clicks a button, what happens when a user clicks on a button in the browser, it's going to add whatever logic is supposed to happen in that button to this lowest priority queue. And then when it has nothing to do in here and there's nothing to do in this queue, only then it will check the on click. And oftentimes in an on click, you might have a API fetch. So how that would work is you're executing here, you check this queue, it's empty. Okay, the user clicked on something, let's handle that. Then in there, you see that the users or like the program is trying to fetch data from the browser. So add that to the web API. It's going to take some time. So check, keep going back to the main queue, execute lines of code, and then nothing's here. So check, oh, the API request is done, add it to the main queue. And that's how you should visualize it. Constant loop around these three queues, but whenever it ends in one, it prioritizes it till it's fully done. So it's going to be executing code, then there's nothing left. Okay, check. Executes completely. There's nothing left. Check and go back. So the main takeaways, if you're ever in an interview about JavaScript or full stack development, JavaScript is a single threaded language. It can only ever execute one line of code at a time. In order to avoid pausing and waiting for code that is asynchronous, it has a different queuing system with different priorities where when something is waiting, it gets added to a queue so that JavaScript doesn't get stuck on slow lines of code. Those are the main takeaways. All right, so hopefully now I've built some kind of like mental model that you can use to understand how the underlying code is being executed by the programming language you're using. And now let's actually get to React, which is just a front-end framework. So using JavaScript, they've built a framework that makes it easier to build applications. And let's take a look at this somewhat complicated component, I would say. I would doubt most people really understand how useState, useRef, and useEffect really work. It just has one input, which has a value, and that value is the state variable. So whenever you're texting, whenever you're typing into the input, React is constantly re-rendering the component. And when it detects or when the input changes, it actually changes the value. So we have a state that changes and updates the UI. But we also have a useEffect. And a useEffect just declares a dependency with a variable that whenever it changes, it basically, you tell it execute what's in the effect. So you have an input, whenever it changes, update the actual state variable, this one. And whenever this one changes, actually run the useEffect. So that's how that works. And in this useEffect, you just quickly check to make sure that there is actually some text in there. And if there is, then use the useRef, whatever function is in here, to call that function. So if this part doesn't make sense yet, I'm going to explain it. It's the most complicated part, so just relax. useRef in this case is storing a reference to a function. And right now the function is completely empty. It's basically just getting called and doing nothing. And in here, we actually set that reference to be a function that logs something and then calls a promise. And just visualize this as making an API request. So this is just making an API request. And this is using a web API, which is set timeout. And what that does is it schedules a function. So in this case, log this after a certain amount of time. So here it's after 0, but you could also make it execute after 1 second. So it basically says like schedule this function in 1 second. When this runs, it's going to look at what the current is. And in that case, it's this function. But now things can get kind of complicated when a user quickly types, like let's say the word ABC. Because what happens is this gets fired 3 times. Because the input changes from nothing to A, from A to B, and from B to C, which means that this useEffect gets fired 3 times, which means that this function gets called 3 times. And in each of those calls, you're creating a promise. It's the same thing as an API request. You're creating a function to be scheduled in 1 second. So how does this work? There's a bunch of components and things happening at the same time. And the point of the use reference here is that it's exactly like useState, except that it doesn't trigger a re-render. So how React works is, in this case, let's say you have this is the actual or let's call it the React render. So you're going to have 3 of these, right? One for A, one for B, and one for C. Now, in each of these, they have their own environments. So you have this one, and this one. And let's call this one when the user types A, and this one when the user types B, and this one when the user types C. So when the user goes from nothing to A, when they type A into the input, you are going to have a like a render, and in that render, all of the variables are enclosed. So in that render, text, here I accidentally typed RR. In that render, text is A. Text is equal to A. So when this function, if this function were to use the variable A, or the variable text, sorry, it's going to see only A. And in this one, in this render, it's going to see text is equal to AB, because you typed A and then B. In this one, ABC. And they're all also, if you didn't have this reference and you just had this function, they would all also call their own version of the function with that variable, with text as A. If this function would somehow use text to get data, so imagine the text, you immediately start, finding books that are related to the title, and he's about to type Aristotle, Aristotle or whatever. And we use that data to actually fetch the API, then you're going to have potentially a problem, because they all have their own reference to this text, but actually you want to make sure you're using the latest one, because that's what the user would expect. And that's where useRef comes into play. So useRef is something that is used by all the components regardless of which rendering cycle you're in. So now, instead of if we were to use the function without a useRef, then it would look like this, where they each store their own function. But now, no matter where you are, this useRef is going to use, they're all going to use the same reference to the function. So you don't really have that issue anymore, because useRef is shared across different renders, and useState is as well. So whenever the function executes, it's going to be the same reference, which is going to be the latest reference. So by the time text is equal to ABC, these older ones are not going to have their old references. They're going to have their new ones. And they're also going to have the latest version of the useState, which is going to be ABC. So that is, I zoomed out too much. That is essentially what useRef does versus useState. They both share information through renders, but when a reference changes, it doesn't update the component. So if you were to change this actual function, it won't trigger a re-render because it's not a state variable, whereas state will trigger a re-render. So, okay, now we kind of understand what useState is, we understand what useRef is, and we understand what useEffect is. So already the 3 most important hooks in React. And the final thing is just, seeing how the actual event queue, which is what we talked about here, works in practice. You're going to use, the useEffect is going to change whenever text changes. It's going to fire this function. This function is going to immediately execute this line of code because it gets priority. It's not waiting on anything. Promise.resolve. This is something that is, it's supposed to be like an API request, so it takes time. So the promise resolve gets added to the micro queue, and it doesn't get executed yet because it's supposed to take time. It moves on to the next function, which is set timeout. And what set timeout does is it schedules this function, or this one I should say, to be fired in 1 second. So it adds this line or this function to the macro queue to be executed in 1000. Now everything's run. It has nothing left to do on the main one. It checks the web API one. It sees that this promise, this API request, is finished. It's resolved. And then what does it do? It executes this function, Microtask promise resolved, for the text that's written. And then it's finished with the micro queue. It goes back here because this has priority. It then sees there's nothing to do in here, and it checks this because this has priority. It sees there's nothing there because the promise ran. And then it checks finally the macro queue, which is the function that was put in here. And then it executes that. So what you're going to have is console.log this. Then you're going to have a break. And then this is going to get next priority, console.log that. And then after 1 second, you're going to get a console.log this. So yeah, that's kind of a quick summary of some of the more lower level details of React and the event loop in JavaScript. Hope you guys enjoyed this one.